what is the minimum velocity with which a body of mass m must enter a vertical loop of radius r so that it can complete the loop. Okay, we'll understand this one with the help of a simple diagram. Okay, assume this is the vertical loop. Okay, and this particle is moving with a velocity v, and the topmost here, the same particle will that is the normal force will be acting in this direction, and in the same it is here also, and the mg will be also acting in the same direction. Then we can write n plus mg is equal to mv square divided by r. Then will get cancelled and n is equal to 0 in this case. Then v is equal to under root of g times r. According to law of conservation of energy, according to law of conservation of energy, then according to law of conservation of energy, I'm going to take this one as a u here. Now, then half mu square is equal to half mv square plus mg times 2r into 2. Then half get cancelled, m will get cancelled. Then u square is equal to v square as it is plus g is there and 4r, that is 4gr. Then we know here that v is equal to under root of gr. Then in this place I can write if I'm going to write, that is under root of gr whole square. The square and the root will get cancelled. Then u square is equal to 5gr. Then u is equal to under root of 5gr, which is the minimum. It is the minimum. For example, if u is equal to more, if u is equal to more, then v is equal to under root of gr, then the normal force is not equal to 0. That means it becomes n is greater than 0. So for this condition, if it is the minimum velocity, then under root of u is equal to under root of 5g or is the right answer. Option D is the right answer.